Hello! Time to talk about what to do with a conditional statement and a biconditional statement when it comes to truth tables, and this will wrap up our journey with rules before we get into the real meat of this. Okay, first a conditional statement. Recall that conditional statements are those if-then statements. You have a statement like, let's say you have a statement like this, like if Simon makes an A in math, then I give him $50. And you might be thinking, wow, that's a lot of money for an A in math, but my son really struggles with math. Believe it or not, 2 math teachers, and we have a son who struggles. We think he has a learning disability, and we're working on figuring that out. But still, I don't think it's that unreasonable of a reward if he works really hard and is able to make that A. Anyways, that's beside the point. Okay, so we have an if-then statement here. We have a conditional statement. If the Simon makes an A in math is the antecedent, that is the, what has to happen, that's the requirement. And then the follow-up is if that requirement occurs, then the follow-up is that I will give him $50. So in this one, if it's true that he makes an A in math, then I'm expected to follow up and give him $50 right here. If that's true, if I do that, then I've been telling the truth. I'm not a liar. Woohoo! But let's say he fulfills that requirement. Let's say he keeps his part of the bargain and makes the A in math, but then let's say all of a sudden I'm like, oh, you know what, never mind, I'm not giving you the $50. Oh boy, now I am a liar. This is where he made the A in math and I went back on my promise and didn't give him the $50. So first scenario, he made the A, I gave him the $50, promise kept. Second scenario, he made the A in math, I didn't give him the $50, promise broken. Third and fourth scenarios are a little different. In the third and fourth scenarios, he didn't make his A in math. He might have worked hard, but maybe he just couldn't quite do it. Maybe he made a B or a C. So at that point, if the antecedent doesn't get met, then the follow-up, the giving him $50, can go either way. If the initial condition wasn't met, dang, I wish I would quit drawing those lines. I am free to follow how I please without breaking a promise. So if he doesn't make the A in math, but I still follow up and give him the $50, maybe I feel bad, that's okay. We have a true there because I haven't broken it. If I give him the money, I haven't broken any promise. The promise only specified, if you make the A in math, then this is what's going to happen. But it never talked about what would happen if you didn't make the A in math. It never specified that. So that leaves me open to do whatever I want. So I can either give him the $50 or I could not give him the $50. If I don't give him the $50, that's still understandable. It's kind of like, oh, I kind of figured that would happen because I didn't make the A in math. But if I do give him the $50, oh wow, that's a surprise. Might not be the best parenting choice because, you might think, oh, I can do whatever I want until I get $50. But I haven't broken any promises. So with the conditional statements, think about promise keeping. The only time you've broken a promise is if the initial condition was true or met, but the follow-up was false or didn't happen. The part after the then, the consequent. Every other result, you're going to put a true. Okay, let's do a quick, well maybe not quick, but let's do an example truth table that involves a conditional. Okay, for this symbolic statement, we need to do a truth table and see what conditions come out to truth, true versus false. And we're going to need to set up this truth table with PQR, because that's what's in the statement. Remember, PQR, you're going to have under P, 4 true, 4 false. And under Q, you're going to have 2 true, 2 false, 2 true, 2 false. This is a standard setup every time you have PQR. Memorize it, because it will not be provided for you on the test. Okay. And then we can, after we get the initial setup, then we tackle the statement. This statement does have parentheses, and in the parentheses it simply has an AND. So we'll go ahead and put the Q and R and make a column for that. Now remember the rule for AND, they both have to be true. You know, if I promise the playground and a kid's meal, I'm expecting both of those to happen. If only one of them happens, or if neither one happens, then I haven't fully kept my word. So we got true and true is true, true and false is false, false and true is false, false and false is false, true and true is true, true and false is false, false and true is false, false and false is false. So there, that column took care of the parentheses, the Q and R. Outside the parentheses, we have a negation and a conditional. Remember, negations get done first. So let's take care of not P. So the P column just gets switched to 4 falses, 4 trues. And then finally, we're going to take what we got from the not P column and then look at the Q and R column, applying our conditional rule. Conditional statement is only false if you go T to F. Otherwise, it's true. So not P column, Q and R column. False to true is true. False to false is true. Remember, I know that sounds weird, 2 falses making a true, but remember, that would be like him not making the A in math, so then I did not follow up and give him $50. So that's still, I've kept my promise, still it's true. False to false is true. False to false is true. True to true is true. True to false is false. It's the only time a conditional is false, is T to F. True to false is false. True to false is false. And there you go. That's the answer column, because that was the last column we had to do. And since the very last thing we did was a conditional, this is a conditional statement. Remember, whatever your last rule is, that's what kind of statement you got. Alright, so there's an example of doing a truth table using conditional. Alright, I want to do another one, another truth table here, with conditional. I want to do the statement, if P then Q, in parentheses, and if Q then P. Okay, so this one just needs the P and Q to start. So under P we have 2 true, 2 false. And under Q we have TF, TF. Okay. 2 sets of parentheses, so we'll tackle those first. First set has if P then Q. So we look at the P column, then the Q column. P is the antecedent, Q is the consequent. So true to true is true. T to F is false. F to T is true. F to F is true. Second set of parentheses is if Q then P. The order matters here. So you have to look at the Q column first as the antecedent, the P column second as the consequent. So true to true is true, false to true is true, true to false is false, false to false is true. And then finally, outside the parentheses, there is an AND. So we're going to apply the AND rule using the results we just got, using the if P then Q column, using the if Q then P column. Now remember, with AND, they both have to be true to be true. You know, if I promise the play place and the kids meal, or the park and the kids meal, I gotta do both. So we got true and true, that's true. False and true, that's false. True and false, that's false. True and true is true. Okay. So there's my answer column right there. And this statement is a conjunction. Oh my gosh, that was bad. Sorry. Ooh, I know how to spell statement. Just getting a really bad headache right now from something. So I'm trying to focus here. Alright, so this statement is a conjunction. Because I know it had the conditional arrows in it, but since the very last thing we did was that conjunction rule, that's what makes the statement a conjunction. Okay, so that was your conditionals. Biconditional. Remember, biconditional, you're using the if and only if. Like, you might be saying a number is divisible by 2 if and only if it is even. Here's an example of a biconditional statement. Essentially what a biconditional statement is a conditional that goes both ways. And if you look at the chart here, you'll notice that the final column for the biconditional, the double arrow, is TFFT. And if that looks familiar to you, it should. Because in the previous slide, when we did if P then Q and if Q then P, the final column was TFFT. That's because a biconditional is equivalent to if P then Q and if Q then P. So in words you can use either one and have the same meaning. So I could say if a number is divisible by 2 then it is even, and if a number is even then it is divisible by 2. So that, you know, those words would mean the same exact thing. Or a quick shortcut way of trying to remember this. Notice if both truth values are the same, like TT or FF, it's true. If the truth values are different, it's false. Alright, let's look at an example problem, making a truth table with this. Oh boy. Alright, let's do that one. Alright. Negation, parentheses, P, biconditional arrow, Q. Remember, negation outside the parentheses, that's saying it is false that, or it is not true that. P if and only if Q. Alright, so for our truth table, we just need the PQ to start with. Then in parentheses, we have the P if and only if Q. Remember, if both truth values are the same, it's true. So TT is true, FF is true. If the truth values are different, it's false. Okay, then finally, that negation outside of the parentheses says, take whatever result you just got for the parentheses and negate it. So TFFT becomes FTTF. And this statement is actually a negation because negation is the last thing we just did, the last rule we just applied. I know we had to do the biconditional in there, but whatever your last rule is, that's what kind of statement you've got. Okay, now let's look at a couple of special situations with our statements. If you have a compound statement and you work it out and your final column is all false, then that compound statement, it can also be called something called a self-contradiction. If you do a truth table for your compound statement and you find out the final column is all true, then the compound statement is something called a tautology. And if your tautology was actually also, that kind of compound statement was a conditional statement, it can also be called an implication. You could say, the antecedent implies the consequent in that case, if it comes out to be all true. Okay, so let's look at a couple of examples where this happens. All right, first one. Have negation P and parentheses Q, biconditional arrow, not Q, close parentheses. All right, so this truth table, we're going to need to start out with the P column, Q column. P has true, true, false, false. Q has true, false, true, false. In the parentheses, not only do we have the biconditional arrow, but we also have a negation Q. So we need to do a column for negation Q. So TFTF becomes FTFT. Then working our way through the parentheses, we got to do biconditional between Q and not Q. Biconditional, if they're different, it's false. If they're the same, it's true. In this one, all of them have different. TF, FT, TF, FT, which makes sense because one's Q and one's not Q. So they're both going to be different. So that all comes out to be false. Then working our way out, we have negation P that has to be done before the AND. So the TTFF becomes FFTT. And then finally, got the AND. And since we're doing AND last, this statement is a conjunction. Okay, so not P and if Q, if and only if not Q. Remember, and they both have to be true. We have false and false, which is false. False and false is false. True and false is false. True and false is false. And that was the last column you had to do. And it was all false. So we have a compound statement, it's a conjunction. The last column was all false. So this is a self-contradiction. This is an example of a self-contradiction. No matter what the scenario is with PQ, this statement, when you say it, is always going to be false. Okay, let's see. All right, let's do that next. Parentheses, if not Q, then P, close parentheses, or not Q. Okay, so we just need P's and Q's for this. Under P we have T, T, F, F. Under Q we have T, F, T, F. In parentheses we have a negation Q that needs to be tackled before the conditional arrow. Let's do a negation Q column. If Q is T, F, T, F, negation Q is going to be F, T, F, T. And then we're going to use that negation Q column along with the P column to do the conditional arrow. So we're going to go from not Q to P. F to T is true. T to T is true. F to F is true. T to F is false. Remember, conditional arrow is only false when you go T to F. Okay, working our way out. There's a negation Q, but that's already been tackled right here. So now we can do the R. Or the OR, I mean. I don't know why I said R. OR. Okay, so this column here or this column here. Remember with OR, just one of them has to be true. Only time OR is false is if both are false. You know, as long as if I promise playground or a kids meal, I just got to do one of those, and then I'm good. If I do both, it's great, but all I got to do is one or the other. If I don't do either one, then we have a problem. So we've got a true or false. It's going to be true. True or true. True. True or false. True. False or true. True. Alright, so we just did the OR rule. So this statement is a disjunction. The OR rule was the last one we applied. So the very last thing you do is what kind of statement you got. It's a compound statement. It's a disjunction. And notice that in that answer column, the results were all true. So this kind of statement is a tautology. If you have a compound statement and the final column's all true, then you have a tautology. That's a fun word to say. I don't know why I like saying it. Tautology. Alright, one more example. Let's see here. Maybe I should do PQR because I haven't done very many of those. If I can find a good one to do. It's kind of hard to find though. Oh, here's one. Here's one with P's, Q's, R's. Let's do it. And it has brackets. I'm going to do examples with some of these other wilder things you'll see. Okay, so we've got P, Q, R in this one. So we're going to have to start with that standard 3 columns for P, Q, R. Remember, P will have 4 true, 4 false. Q will have 2 true, 2 false, 2 true, 2 false. And then R will go TF, 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 TF. Okay. Now we got brackets, which are just another way of doing parentheses because there's parentheses inside the brackets. So when you have parentheses inside of parentheses, you end up using brackets on the outer ones. If you have even more, like let's say you had parentheses on the inside, brackets on the outside, and you needed more, you would see braces. So that way you can tell them apart and tell what's what closes in what. Alright, so innermost parentheses first. So let's do the P or Q first. P or Q, just one of them has to be true because it's OR. Both can be true and it's true. Only time it's false is if both are false. So in this one, all the way down the first 6 rows, 1, 2, 3, 4, 5, 6, there's at least one true in there, in some cases 2 trues. Rows 7 and 8 have 2 falses, so that's why we get false. Okay, working our way out, we have the P or Q and R. So the P or Q column and R column. And they both have to be true to be true. So T and T is true, T and F is false, T and T is true, T and F is false, T and T is true, T and F is false, F and T is false, F and F is false. So one time it's true is if both are true. All the others are false. Alright, and then working our way out of that. The other set of parentheses is a P or a Q, which we've already got covered right here. So we don't need to do it again. So we can go ahead and do our conditional arrow. And since the conditional arrow is the last thing we're doing, this statement is a conditional. Okay, so the P or Q and R column to the P or Q column. True to true is true. False to true is true. True to true is true. False to true is true. True to true is true. False to true is true. False to false is true. False to false is true. Remember, conditional arrow, it's only false if you go T to F. And we never did that here. We always went either T to T, F to T, or F to F. And the final column is all true. So this compound statement, this conditional, is a tautology. But since it's a conditional that's a tautology, we can also say it's an implication. It's a tautology, but it's also an implication, because of it being a conditional tautology. Okay, well, I don't want to do too many because you got to have enough to practice. But anyhow, there you go. There's some examples talking about conditionals and biconditionals, and then also those special cases where you have self-contradictions, tautologies, implications. Many times your answers are going to be a mix of T's and F's, and in those cases they're not special cases. The self-contradiction has to be all false, tautology has to be all true, implication has to be a conditional that's all true. So a conditional that's a tautology. Alright, so practice, practice, practice. Next lesson we're going to be using what we just learned to compare statements and figure out what statements are logically equivalent to each other. So you're going to be using plenty of truth tables to do this, so make sure you get lots of practice in, and I look forward to seeing you again soon.